these fellowship opportunities that we've got in the university, as I said, it's a new scheme. We've not had it here before, but I think they've really set this up in a really nice way for someone who's looking to develop their research career and then go on to become an academic, someone in faculty like myself. Essentially, it's a 5-year funding scheme, but then you automatically transfer into a lecturing role. The first 2 years is entirely devoted to research. You're given a startup fund. There's a mentoring and development program to help you out. And this is all what they want you to try and do, is build an outstanding track record of research, innovation and impact. And what they're looking for is you to do something which complements and extends our current research in acoustics, in this case, while building novel activity. They're really looking for the next set of world research leaders. So they want you to come along, work with us, so it complements what we already do in our current strategies, but takes us into new areas as well. And they're really keen on developing partnerships with, whether it depends on what you want to do, but that could be with industry, that could be with public sector government, that could be with charities, third sector organisations, whoever is kind of most appropriate. In the end, they're wanting this to feed into teaching. So after 2 years, you'll start having some teaching because you're working towards a lecturing position. And so they want this research then to feed into the teaching. And I'll talk a little bit more about this as well. They're very keen to try and deal with diversity. One thing you'll notice is the staff here are, for example, mostly male, and they're keen to have more lecturing staff who are female to give more diversity. And you can think of diversity in other ways as well. And so they're really keen to support trying to get a diverse background people applying. Now I've put 3 links and a 4th link, which are the sort of key documents that you need to look at. I'll put a link in the chat where you can pick those all up, this PowerPoint, so you can get all of them. But basically, if you go to the web page that we had for this webinar, you'll notice it's linked to the main university page, and there's actually 3 different pages then that you really need to look at to get to the bottom. So it's a really good scheme. I think they've drawn it up really thinking about how do we get the next world leaders, and I think it's kind of a really unique opportunity. I think one thing to emphasize here is you're competing not against just acoustics people for these posts. You're competing against anyone wanting to do any research across the university, so it's going to be highly competitive. And for that reason, we're holding webinars like this, but we're more than welcome to help you out, trying to give you some advice on how to make an application which works, which is part of what this webinar is about. Now, to give you a sense of just what Acoustics at Salford is all about before going around my colleagues and looking at particular areas, we've been around here over 60 years. We've run courses since the 1970s. We're about, in terms of research active staff, there's about 12 of us. And then we've got 10 commercial staff, some who I can see on the screen as well. So one of the things which makes Acoustics at Salford unusual is it has a big commercial arm who do R&D with industry, testing and things like that. And are very integrated into the rest of the department as well. So we work both on fundamental research, but also on very applied stuff for industry. We have 6 research fellows at the moment, about 20 research students, and we bring in quite a lot of grant income. And as I said, with this commercial arm, we bring in quite a lot of commercial income as well. Now, something I will mention is that actually we're going to be moving out the building I'm stuck in here into a new acoustics building. It's not quite signed off by the university yet, but we'd anticipate in 2025 that we'll be in brand new laboratories as well, which is very exciting. More to follow on that later in the spring when it's all being finalised. In terms of the laboratories we currently have, if you're wanting to do acoustics, we have probably everything you could want. There's a picture of the big rev room, we've got transmission suites, we've got multiple anechoics, we've got listening rooms, and we've got a calibration lab and extensive measurement systems as well to support all those. So we've got lots of kind of measurement capability, if that's the kind of thing that you're interested in, if you're doing a measurement-based subject, and very big and impressive laboratories. Now, when you come to write your application, it's going to ask you to sort of kind of align, how does your research fit into what's already going on? And if you look at the fellowship pages, it's got a couple of paragraphs that I wrote about the strategy for the research centre, the Acoustics Research Centre. So it's important you refer to that in your application. And we broadly split our research for the future into 2 areas. One is around health, well-being and accessibility. So there's some obvious sort of healthcare stuff like I have hearing aid projects, as you'll hear in a moment. We do work on accessible audio for things like AR, VR, and television. But we've also got to think about things like environmental noise. Noise damages health. So that's some of the aspects of noises around actual that. And then there's a bunch of us who also work on things like bioacoustics, the effects of noise on wildlife and things like that. So anything in the sort of health, wellbeing, and accessibility line, whether that's a healthcare technology or something that improves human health or animal health, there's lots of things there that we're kind of interested in. And some other things will be mentioned by colleagues, so I'm not going to say them all. So that's one big area. And another big area is industrial acoustics, anything that supports industry in the UK and globally. So that could be in the built environment. We do a lot of stuff in architectural and building acoustics. We are now the National Institute for Airborne Acoustic Metrology, a designated institute. That means we do the function that NPL used to do for airborne acoustics in terms of calibration and the fundamental measurement of acoustics. We have stuff in vibroacoustics, structure-borne sound through products. Big lot of work now in e-mobility and drones going on at the moment. And I think one thing you could say about a lot of our industrial work is it goes back to the human, perceptual-based engineering, where perception drives what we're doing. I'm sure John will mention high-intensity testing in a moment about rattling satellites around with sound. And then we do work in audio, with people like BBC R&D, modelling of sound using computers, and machine learning, obviously, nowadays. So you want to try and fit your sort of kind of application, your research, sort of kind of what you're trying to do, broadly into one of those two areas or both of those areas to fit the Acoustic Research Centre strategy. So what I'm going to do now, I hope that gives you a sense of what the fellowship's about, what we're about very broadly. Is I'm just going to go around the room with my colleagues, each have a different slide, and I'm going to ask them to talk. If you could keep it to 2-3 minutes, people, because actually you do the maths. If we do 5 minutes, we'll run out of time. 2 or 3 minutes each. So we're going to do brief. And I thought, as we're going to brief, I'll model that by doing it first. So I'll talk about my research. So I'm Trevor Cox, I'm Professor of Acoustics, and I should have said at the start, if you've got questions about the scheme, get in contact with me in the first instance if you want any help. So my original area of research was actually in architectural acoustics. I did a physics degree. My more unusual architectural acoustics recently has been modelling Stonehenge, but I have past work on things like schools and concert halls and studios. I was particularly in early days known for doing work on diffusers. So I put a picture of a meta diffuser on a paper that Noe Jimenez did with me. So actually treatments to try and make things sound better in rooms. And the work I do is a mixture of simulation models, measurement techniques, and also design in architectural acoustic space. I've also done a lot of work in audio stuff and audio reproduction. I ran the S3A project for Salford here. Here's an interesting thing called media device orchestration, where you make ad hoc arrays of loudspeakers to create spatial audio out of a set of mobile phones, is what that's all about. So that's another aspect. And then the sort of third aspect of my research, which is more recent in terms of getting projects, is looking at hearing aids. So I've got two big projects. One's called the Clarity Project. One's called the Cadenza Project. You can find both of those online, which are running machine learning challenges to try and improve how music and speech sounds for people with a hearing loss. So improving hearing aids, improving devices that reproduce speech and music. So one aspect of my work, which has gone back to the 1990s, has actually been working on machine learning. So in the list, I've got sort of a list of things I'm kind of generally interested in. I think I've covered most of those. So I hope that gives you a sense of the kind of work that I get involved in. So moving on from that, Bill, if you'd like to sort of give us a quick overview of what you work on.
Sure. Hi, everyone. My name is Bill Davis. I'm also a professor here at Salford of psychoacoustics. In my case, I'm probably best known for soundscape research. I've led several projects on soundscape. I started out, I suppose a bit like Trevor, my PhD was in auditorium acoustics, but I just got more and more interested in why people hear what they hear and what makes one thing sound different from another thing. So I suppose these days you could say that I'm sort of broadly interested in the response of humans to complex, sort of realistic sound fields. So still including a bit of room acoustics, but I suppose probably more soundscapes, sort of general urban environment. More recently, I'm pretty interested in topics that fall under the heading this sort of relatively new research concept of aural diversity. So that's basically not assuming normal hearing, not averaging, and asking questions about how different individuals and different groups differ in their hearing perception and response to different kinds of sound. There are many large research gaps there. If you're interested in having a crack at one of those, then yeah, then that would be interesting. Yeah, there's some pretty pictures on there of oh, I don't know. There's my erstwhile colleague James Woodcock, a postdoc I worked with, wearing an eye tracker, and there's a graph at the bottom with some results where we were attempting to show how pupil dilation predicts sort of cognitive load and attention effects. Yeah, I think I'll shut up there now.
Thank you very much, Bill. That was suitably the right length as well. What a professional. If I move on to John Hargreaves, if you'd like to sort of kind of chat a little bit about the work you've done. You've not got too much on this slide. It won't take too long, will it?
Yeah, you said I had too much, and I responded by making everything smaller and then adding some more things, I think. Hi there. So, yeah, thanks for joining us. So my interests are mostly in physical acoustics, so quite different to Bill's. So lots of things to do with kind of measurement of sound fields or reproducing sound fields. So mostly to do with airborne acoustics. I'm interested in fiber acoustics a bit, things like material characterization down in the bottom of the center. But a lot of this is really to do, kind of hinges on computer simulation, really, which is my main area and what I did my PhD. It's my main research area. And so things are often to do with kind of like trying to set up measurements that you would closely replicate in simulation, so you can kind of understand in more detail you know what's going on in a particular case by comparing the simulation to the measurements. I'm also therefore interested in sort of trying to tune simulations to be more accurate. So things like source characterization comes in as on the bottom left, kind of measuring the directivity of the loudspeaker or however you're informing the environment, and the materials down in the bottom center. There's a picture from a publication using holographic microphone array techniques to measure materials. And this kind of leads then on into other kind of parallel areas as well, which is, okay, so we're going to measure a sound source. Could we design a better sound source? And so I get to things like loudspeaker design and measuring the response of speakers, designing speakers to have specific responses, or potentially designing speakers to have just really high sound pressure levels as well. So Trevor mentioned the high intensity testing I've been involved in for satellite testing. And part of that is just about people making really loud speakers, but a lot of it's actually about how you then control all those speakers to give you some particular type of sound field, often trying to reproduce what you get in a rev room. So lots of stuff to do with using kind of multiple speakers and the way you drive multiple speakers together in arrays or analyze data from microphones in arrays. It's got a lot to do with the sort of boundary element simulation algorithms that I'm used to as well. So it might seem like quite a disparate group of things on this slide, but in my head they all kind of tie together and are quite similar. So if you're interested in any of these topics, be it simulation or measurement or a kind of array-based techniques, then please get in touch, because I'd love to grow our area and have other people working in this area at Salford as well.
Thanks very much, John. Yeah, if you've got a particular topic that interests you and a particular member of staff you want to talk to, I'm sure they won't mind you getting in contact as well, rather than getting in contact with me if you have subject-specific stuff you want to discuss. So I'm going to talk for Joshua Meggitt, because he's actually teaching, so he can't be here at this moment. But what Josh does is he works on vibroacoustics and structural dynamics. So he's really interested in how sound goes through objects, modeling it and measuring it. We've got some sort of fundamental work we've done on things like block forces that's left international standards. And so he's looking at sort of kind of hybrid modeling, using finite element SEA combined kind of techniques, and also dealing with things like how do you characterize components, so how do you characterize sources. And he does it for a variety of things. So he's worked with people like Dyson and Boeing, so sort of kind of working on actual products or bits of building. He's also looking at as well at ground-borne vibration he's looking at. So if you're interested in structure-borne sound, vibroacoustics, then Josh is one of 2 members of staff who specialise in that. I'm sorry he can't be here today, but he's teaching. I don't know, did I see Bruno in the list of people? Sounds like maybe he's not here, so I can just talk a bit about what Bruno does. So Bruno Fazenda works on acoustics and psychoacoustics. So his original research was on low frequency modes in rooms. And he's really interested, a bit like Bill, in psychoacoustics. So whether that's in an audio system, like a spatial audio system being used in a virtual reality system, or in terms of sound quality. I did a big project with him about the audio quality of user-generated content. He's currently working on the Cadenza project I'm on, which is about trying to improve the mixing of music for people with a hearing loss. So intelligent mixing algorithms is another thing he gets on. So if you're interested in that kind of side, also potentially the using of sensors to improve music, I think Duncan will probably mention a little bit of that in a moment, so I won't cramp Bruno's area with that. And he also comes from a room acoustics background, and like me, the room acoustics he more likely does nowadays is in archaeological acoustics or archaeoacoustics. So sorry he can't be here today. We're in the middle of a teaching day, so no doubt he is also busy. But I can see that Duncan's here, so my next guest will actually be able to talk. So over to you, Duncan.
Thanks, Trevor. Hi, everybody. My name is Duncan Williams. I'm a lecturer here at Salford. I've been here for 3 years. And my main interest is in understanding music and trying to create tools which will assist us with music. So my first degree is in music, and I am more or less a failed musician turned engineer. And the things that you see on the slides here are examples of those kinds of projects. So in the top right is Tiny Temper, the rapper. He used some of our technology a few years ago where we tried to attempt to use his brainwaves to help him create music. So to help him create music is the key word there, rather than to use a GPT type of technology to replace musicians, which we've been kind of kicking around in a group chat separately, and I suppose would also be an interesting thing that you might consider for the future. Other couple of small projects on there that you can see, different kinds of sensors, taking measurements using surround sound and a similar kind of equipment, all working with sound in the context of video games, VR and entertainment. And the young lady in the bottom left there is wearing a VR game where she dives into the deep sea and talks to the creatures inside the sea, so sort of harnessing the power of sound to try to assist humans in the future. Essentially, I'm probably more interested in the fun side of sound and music than in making the world sound better from an industrial point of view. And if that sounds good, I'd love to hear from you.
Yeah, and it feeds into our sort of health and well-being area, because of course music is so important to being human and so important to our health and well-being. So just to give you that link into our strategy for what Duncan's doing. Thank you very much, Duncan. And then moving on to Ben, who is Ben on the line? I don't think I've seen Ben today. So I'll pick up on that and talk about what Ben Shirley does. So Ben's a reader in accessible and personalized audio. He's got various aspects to his research. So one thing he did was he worked on sports audio, working out how to improve the production of sports audio in projects, which has led to a company called Sound that sells quite a lot of AI tools for use in production that he kind of co-founded. So that's one kind of aspect, is actually, you know, broadcast technologies. And another aspect is looking at accessibility. So he's had a long history of working with visually impaired and people with hearing loss, and look at how we might improve the sound that they receive. To give you an example, the middle picture there is from Casualty on BBC One, and they had to work together to produce an accessible mix for that kind of that program. And so he's very keen on trying to make accessible television, but that's now moved on to look at access to other stuff, and particularly we're thinking about virtual experiences you might have of museums, and with VR and AR and XR taking over and becoming more important. So that's kind of the areas that Ben is primarily interested in. And then moving on from Ben, we have Antonio, who's here. Antonio, would you like to just chat a little bit about your research topics?
Yeah, thank you, Trevor. Hi, everyone. So Antonio Torija Martinez, reader at the University of Salford. My main expertise is in environmental acoustics. As you can see in my slide, there's quite a lot of things there. So my research is quite diverse. So I'm going to start talking about perception-driven engineering. So this is something I'm trying to do, is understanding how to connect perception of noise to how the noise is generated, so you can influence the design of a variety of products. In this case, could be a drone, could be an electric propulsor, could be an aircraft, those sort of things. So I'm just mentioning some of my projects here. So one is on the left is mainly our acoustics, quite focused on understanding the sound generation of an all-electric propulsion system, all the measurements, validation of models, to understand again how a community could be affected by the operation of these new vehicles. I have an interest in urban air mobility or advanced air mobility, trying to understand the noise generated by these vehicles and the impact they will have on communities. These are new vehicles, new configurations with impact on with significantly different operating conditions. So we have also a project on drone noise, which is small to mid-size vehicles. We do measurements and way of reporting and assessing the noise produced by these vehicles. I also do some research on e-mobility and decarbonization. So in this case is so we know that it's a transition towards more electric mobility. So there are significant challenges there. For example, if we are talking about micro-mobility, these vehicles, these scooters, they will need to be, so you will need to add some alert signals in order to make them noticeable and minimize the potential hazard to pedestrians with a particular interest on blind, partially sighted people. Also, we have things like a transition to net zero in the UK, in Europe in general, the replacement of, for example, gas boilers with air source heat pumps. So there are significant challenges there, new sources. There's a need of understanding how the noise of these machines is going to be, how it's going to be propagated in built environments. So all of that are things I'm doing at the moment. So in terms of specific research topics, I usually working on perception-driven engineering, e-mobility noise, aircraft noise, and also this psychoacoustic connected to perception-driven engineering. So we have contact with a variety of industry and universities, and also for the specific topic of drones and urban mobility, we have an open collaboration with NASA in the US. So we are exploring, expanding our capabilities for modeling and analyzation for these new vehicles. And I think that's a summary of things I do.
Thank you very much for that, Antonio. And Francis, would you like to sort of give us a quick overview of your research?
Yes, thank you, Trevor, for organizing this, and good afternoon, everyone. My name is Francis. I'm one of the researcher within Acoustics Research Centre. I came from a background of electronics and computer science. Over time, throughout the CPD, I gradually sort of convert myself into one of the active researcher in acoustics. So gradually appreciate the problem and try to make use of some of the computational techniques to solve the problems. So over a long time, I just call myself a service department acoustics. So my area and my actual expertise evolved over time when this subject area moves forward. And at the moment, I have mainly three big blocks of research interest. One is the general sort of machine audition. By saying machine audition, we just try to use a computer, algorithms, AI, software computing, whatsoever, to try listen to sound and make sense out of it. For example, the current interest is the kind of room acoustics from natural sound sources, and we try to appraisal the room acoustics in terms of objective parameters and more from naturally occurring sound sources during the performance, during the in-use situation, etc. And the second aspect alongside this machine audition of acoustics is the speech intelligibility and speech quality assessment. And certainly this is often concern of everyday life, especially in today's kind of interconnected world through the appliances, through the applications like Teams, etc. And the next aspect of my kind of interest in the machine audition kind of field is audio content analysis, and which is to look at various kind of old archived recording and whatsoever, try to extract metadata, classify them, and find a way to best reuse them. And one last but not least, with this kind of more and more kind of insecure, I tend to say that, but we try to make it secure, use of IT sort of technologies, and security and the privacy is becoming an important concern. So the last part, which is also quite active at the moment, is robust speaker recognition. This is not a problem of to find out what the talker is actually saying, but a biometric to determine who is the talker. Okay, so this is the sort of machine learning based machine audition, so the branch of my work. The second branch of work in the middle block of my kind of slide is the synthesis using the generative network. It's pretty much new to me. I've been working in this field for literally just about 4 or 5 years. Essentially, we will look at something slightly different from Google or whatsoever big players' approach to this generative AI model for sound track and speech synthesis. We try to look at relatively small data set and try to get some sensible outcome out of it for a variety of reasons. For example, we try to actually use the generative network to synthesize a few notes or a few short segments from for audio track. The purpose of this is, for example, if you try to use some sort of separation algorithm to get multiple track being mixed down to a single track or fewer tracks, and then you try to reconstruct the original individual track after the separation, and we usually can experience some sort of large distortion. And for the worst few segments or notes or whatsoever, if we could listen to the discourse and try to resynthesize those and use the synthesized elements to replace that, there is a potential to actually restore the audio soundtrack. So this is an example. And a similar scenario applies to speech. So what our approach here is slightly different from the sort of Google's approach or many big players' approach. They rely on large data set and big data. But what I'm trying to use and to do is try to use the minimum available discourse information to get the best bet out of it. The last bit, but not the least bit, is the machine learning and the soft computing for biomedical engineering that is in line with the AIE sort of strategy. At the moment, that's been my long-term interest, started from day one into my academic career. So that kind of initiative rekindled my interest. The machine learning and software computing, and the current focus is on the ECG and the EEG signal separation and the pattern recognition. And there's an ongoing project, and fairly recently, where we had a meeting with the Vice Chancellor, and she is trying to help outreach the supporting bodies for this, is the use of spontaneous sound or sort of induced sound from human body to actually make some sort of diagnosis. The current application involves what is described in the right-hand side picture. We try to knock on the knee of a subject and use some sort of transducer, including something very simple, such as an electronic stethoscope, and then listen to the vibration. Throughout the modal analysis, then we can give the specific stiffness of the bone, and from there, using some sort of machine learning, we can predict the likelihood of fracture, especially for aged people with some sort of osteoporosis or the early stage of osteoporosis. Certainly, I'm interested in, as a signal processor, always interested in the generic sort of denoising. That's a constant theme for us, and I'm particularly into, in the past 2 years, the use of singular spectrum analysis. Some people call it the caterpillar algorithm or whatsoever, to look at the difficult to remove noise, for example, wind-induced noise from the microphone signal, etc. So that's pretty much the general sort of 3 blocks of the current and ongoing sort of research interest. And if anybody is interested in or would like to sort of join this working force, and please do get in contact. Thank you very much indeed.
Thank you very much, Francis. There's a few colleagues we haven't got slides for, I'm just going to mention, but you could always look on the Acoustics Research Centre website for more. So I'm thinking of Dr. Olga Obnova, for example, who works in theoretical acoustics, particularly on porous and metamaterials, and has been doing that for a very long time, is a really well-known expert in that area. So if you're interested in materials for noise control or for blast control or whatever it may be, look up Olga Obnova and see the research that she does. I noticed we've also got David Wallington here. You haven't got a slide, David. I don't know if you want to just do a quick 1 minute on the stuff that you do.
Yes, please. I too have been looking for my slide because I distinctly remember making it. If you find my slide, you'll see that there are 3 sections to it. First of all, I'll talk about blast noise prediction, assessment and control. This is industrial acoustics and performed in collaboration mainly with a company called DNV. The second thing you'll see on there is psychoacoustic assessment of environmental sound. Now, we've already touched a little bit on this with the work that Bill's doing and the work Antonio's doing. And our current work on that is about the British Standard 4142, which we're doing on behalf of DEFRA and the Environment Agency, and air source heat pumps, which is mainly Antonio's work. The final one I want to mention, which is in my mind the most exciting, is also done in collaboration with our colleagues from ecology. This also involves Bill. It's about ecological impacts of environmental sound. So this is how sound, for example, from a road in the urban environment might affect the wildlife nearby and the effect that that has on the biodiversity chain. This big project at the moment involves DEFRA, the Environment Agency, and AECOM. We're also putting in research proposals nationally and internationally. So that one's ecological impacts of environmental sound, known as habitats at the moment, but that title might change. They were the 3 things I wanted to mention: blast noise prediction, psychoacoustic assessment of environmental sound, and that final one, habitats, ecological impacts of environmental sound. Thank you, Trevor.
Thanks for that nice summary, David. I'm sorry about the slide. I don't know where it is. Somewhere lost in the cloud somewhere. It's certainly not in this presentation. Just check, Claire, did you want to say anything about the designated institute, or are you just listening in?
wasn't expecting to, but I certainly can do, if you like, just for just a very, very brief bit of information on the designated institutes. We're calling it the National Institute of Airborne Acoustic Metrology, and it's really exciting news for acoustics at Salford, actually. In November 2022, following a long series of discussions, BAYS have appointed the Acoustics Group at the University of Salford as the designated institute for acoustics, which basically means we carry out the function that was previously carried out by NPL for acoustics in the UK. So we are the lead organisation in the UK now in terms of acoustic metrology, acoustic measurement. We have the traceability to Europe and access to the European metrology committees for acoustic measurements. So we basically have taken over that role from NPL there. So yeah, it's quite exciting. The start of a new journey for us. It stems from our work in the acoustic calibration laboratory at Salford, actually, which is a UCAS accredited calibration laboratory. But this will lead us into other areas of acoustic metrology in the years to come. Is that okay, Trevor?
That was great. By the way, that was Claire Lomax, who's the director of the commercial laboratories here, because I called her Claire without giving an introduction. So apologies, you didn't get a proper introduction to what was going on. So what we're going to do, I hope that gives you a sense of what's going on in terms of different subject areas. And what I'm going to do now is to sort of go on and talk about the specifics of the scheme and what I think you need to do in the application. And then we'll go to a Q&A at the end of it. I'll stop recording so we have a Q&A and do that sort of thing. So colleagues, you're more than welcome to stay on, but I'm going into the procedural stuff if you'd rather drop out, if you've got other things you need to do. So as I put this slide up at the start for those who are a bit sort of kind of late into I know a few people joined us a bit late, but the scheme is, I think, really well thought through, and I'm not going to go through it again, but I'm going to put in the chat now the link to these. That page has got these slides on, so you can get these links, so you're not struggling to kind of grab a link off the page and type it in because they're horrendous. But the links are there to the official university scheme. We'll tell you much more about it. So what you've got to do is you've got to apply, and it's a bit like doing a job application. I know some of you are in UK and some of you are outside, so you may not be used to how applications work in the UK. So I wanted to go through a few of those kind of details and talk about it. So the first thing to say is don't apply to one of us. You're more than welcome to talk to us about the scheme, but you must apply through the university. There's a formal application process. One of those links gives you and tells you exactly what you need to apply for. So don't send us a CV. We can't take it. That won't be accepted. You must apply properly through the university system. One thing I would say, I know there's some people interested who are actually currently known to us, you know, maybe past or current researchers. Don't write it as though assuming that the people who are reading this are people you know and therefore know what your skills are. Make sure you articulate exactly what you are as though you're talking to a stranger, because some people making this assessment will not be in acoustics. So you need to make sure you answer all the questions. Don't make assumptions that we know you if we know you for some reason. Feel free to contact acoustic staff for advice. You can contact me, Trevor Cox, in general, if that's just general points. But if you've got specific topics and you want to say, oh, what do you think? How does this fit in? Where should I go? What does this research proposal sound like? Then pick off the member of staff who's most appropriate. If you're unsure who that is, contact me. You can find my email very easily, and I'll pass you on to whoever's most appropriate. So in terms of the application, they're expecting a 5-page CV. And if you look online on one of those web pages, it tells you exactly what should be in there. A covering letter which addresses the person's specification. If you haven't met one of those before, I'm going to show you on the next slide what one of those are. And also stating which research areas the application relates to. So if you look on the pages, it will say there's a link to acoustics, and there's a couple of paragraphs describing the area. So you need to make links back to that. They're looking for a 2-page outline of your proposed research programme, a research plan, which concentrates on the first 2 to 3 years and highlights in particular novelty, planned activities to maximise collaboration, partnerships, knowledge exchange, and plans for that funding you're given. Now, that's what they've said. I would also say they're looking to get world leaders. So I would start your application talking about what your vision is for 5 to 10 years' time. So where do you want to be at the end of this fellowship, and where will that get you and the university? I think it's important to address somewhere in that application. So although the guidance there talks about what do you want to do in the first 2-3 years, maybe in a very concentrated project plan, I think you need to give that long-term vision, because they're employing you hoping you're going to be a long-term member of staff. And like, I don't know, me and Bill be here for 20 years and doing and having a long-term career here at Salford. So they want to see the long-term vision. So make sure you put that in as well, even though they haven't said that. There's a closing date, and that's a UK time and immovable as far as I know. So if you've not done one of these before, and some of you will, so I'm sorry to tell people who know it already, there's a job and person spec. So on the bottom of one of those web pages, you'll find a link to a PDF. It's really important you download and read it. It would be possible to sort of flick past it. And in there is a person specification, which looks like this. I've only taken the top, it's very long. When we come to actually, or when staff come to actually shortlist you at the start and score you in interview, you'll be scored against these criteria, which you can see the first 4, and if I remember rightly, there's 17. To get shortlisted, you have to meet all the things which are marked as essential and are marked with an A, because if you don't, you won't be shortlisted. So it's really important that you address all these essential points if you want to go forward in the process. There are some things mentioned desirable. Now, they're important you answer those because it strengthens your chance of getting into a shortlist and then getting interviewed. But the essential ones are absolutely essential, and the desirable are really important, if I could put it that way as well. So when you come to address these kind of different things, obviously some are really fairly straightforward. Do you have a PhD? But some of which are more descriptive. And I'll just give you some kind of advice on how I would deal with that in an application. I would actually write out what they're looking for. So this thing in black is actually one of the items they're looking for: a good understanding of the potential of non-academic impacts of the research and ways of engaging in order to achieve these. And I would write that out actually in text in the application and write underneath, what is your answer to that? So it's very easy for the person reviewing your application to go, I'm scoring against this criteria, where is the answer to this criteria? So you make life easy for the panel. I think particularly because I think they will have a lot of applications to go through. I mean, this meeting is huge. I've just noticed how many people are here. So there's going to be lots of applications. It's a very good scheme. You want to make sure you'll stand out, and you want to make life easy for the person reviewing your application. Now, when you answer these points, it's an essential, you must answer this point. It's best if you can evidence it. So if you've done something in impact, then non-academic impact, say, you know, I worked in a company where this was done with my research. You know, it's really evidence, it's clear you've done it. But in this, actually, this is talk about good understanding, because you might not have done it so far. So you could write about processes which would gain non-academic impact and show your understanding. So it's always best if it's something you've done and you can evidence, but some of these things will talk about potential, understanding, and then it's acceptable just to state your understanding really of it. This word impact keeps turning up, and I suppose I probably should say it because, again, I don't know how universal it is across the world, but that really means research getting used in practice. So that could be going into standards, into policy, being used by industry, and used by the public. Anything where there's impact beyond a university is when they talk about non-academic impact. And it's a really big agenda in the UK, and I think increasingly so in places like Europe. And they'll be very keen on things they think will make impact. In general, Salford is a university which does research which tries to solve, it talks about real world problems. We do quite a lot of applied research. So they want to know you're going to do research which will end up changing society, making the world better, improving environmental sustainability, all sorts of things like that. Now, in that PDF, you'll also see that it also lists your sort of responsibilities. And I've just pulled the research one out, but there's a research, a teaching, a leadership, and you should look at all of those. But given time, I didn't think I could go through all of them. And I think it's important that you read through those and make sure you address some of these. And I think that the general story I wanted to give was actually highlighted by the second one, which says identify external sources of funding and develop and contribute to funding bids, which is your role. I think one of the important things to say here is they're wanting you to come in, develop a research career and become a research leader. The only way you can really do that is by having you managing a team who does research. You can't, so it's, if you're going to apply here to come and spend 5 years working on your own on a very sort of localized and sort of kind of small topic, you're not going to succeed in application. What they want to hear is you're going to come in, you're going to get resources in to get other researchers working with you and build a team. That's the kind of thing they're looking for. So if you want to become a world leader, you need to have people you work with. To have people you work with, you need to bring resources in. So research funding is a real key underpinning an academic career. If you bring research funding in, that pays for students, it pays for postdocs, everything flows from it because you have resource to do the research. So in your vision, you need to sort of also be thinking about, how do I develop a research career? And I would suggest one of those underpinning things is actually, as well as developing networks, which you might think of, well, writing great papers, which I'm sure you've thought about, it's also about bringing the resource in to allow you to sort of kind of develop actually as a research, you know, develop a group around you. And I'll finish up here and then we'll go into a Q&A. Just to say, this fellowship scheme may not suit you. It might be highly competitive. You might be unlucky. You just might be too busy to apply at this moment. There are other fellowship schemes. So, for example, we supported someone through the MSCA fellowship scheme last year who is now working with us on building acoustics. But there are other schemes as well. So we're always interested in being approached through other schemes. But I'm not going to spend very long talking about them. But you can look them up on the slides if you want to look at those. And they have different deadline dates if the deadline date coming up doesn't kind of work for you. One of the questions I was asked is, this fellowship scheme, is it a one-off? Or will there be another call? I would imagine this is the only call there will be for some years. If they fill all the positions, the money is allocated. I don't anticipate there being another scheme like this for a few years, would be my best guess. But who knows, things might change in the university.